Hello, everyone. Welcome to the Q&A session. You guys cannot, I cannot hear you guys, but I hope you guys can hear my voice very clearly. Today, I will be happy to answer any questions you may have. Previously, we have recorded the video about an introduction of our department. I believe you guys can watch that on YouTube. So on the handouts, I also put the slides. So, okay, so yes, here's the slides I'm going to use. Let's go with full screen mode. View. How do I go full screen? Okay, so that's the full screen mode. Okay, cool. Good. Joseph said you can hear me. Okay, I'm glad. So any questions you guys may have, feel free to type here and I'll be happy to answer. I put it autoplay. Okay. Here.
Oh, yeah, I can see.
Okay, good. You can see the answer?
Yeah.
Oh, cool. Yeah, that's great. I have with me our EO, Maggie here. Hi. Okay, so we'll be hosting this Q&A session. If you have any questions, feel free to type. I think we probably, can you send the slide, link of the YouTube video in case not everyone have seen that before?
Sure.
Just for those of you who might miss the video. Yeah, my video is playing in the background. So Maggie will send you guys the link of the video that we shoot early on about a brief introduction of our department. And just in case that you haven't seen that video, we'll post the link right here. But as a quick recap, I'd like to introduce, so our department is called Industrial Engineering and the Decision Analytics. We are a major that will help you to raise to a whole new level in the area of data modeling and analysis. So our department has Guillermo Gallego. I think he already gave an introduction in the video. You can check it out. The point that he tried to make in the introduction is that making the right choice is very important for your career and for your life. When you decide what to study in your future, you should get informed. That's why we're hosting this information session. And as a guideline, just to tell young people how to make choices, I think you should think about three aspects. So whether the career path or the subject you are choosing is interesting. You yourself find it is interesting. Our second one is whether it is relevant to our world or relevant to the future. Our third one is, of course, whether it is rewarding. Both financially rewarding to yourself, but also rewarding in a sense that, in a way that you have a sense of fulfillment, that you are contributing to the development of our society. The missions of our department, there are three basic missions of the department. First, we would like to build a very solid foundation for of powerful skills in data and analytics, as it is very relevant to our current world and to our future. Second one is that we want to equip students with the domain-specific knowledge to launch a career in the knowledge economy. So there are two phrases that you might want some explanation. The first one is domain specific. by domain specific, I mean in a particular industry. For example, in logistic industry, or in manufacturing industry, or in a financial engineering industry. So this is called domain specific, which means that after you build a solid foundation of data analytics skills, then in most likely in year 3 and year 4, you will be required to take specific courses in one of the domains. We have 4 domains, which I will introduce in detail later. Knowledge economy, what I mean by this is that we enter into a new era. Well, huge amount of data being accumulated. The question is, how are we going to be able to take advantage of the data? The third mission of our department is also to provide the necessary background for those students who want to pursue advanced study. I mean, either master or PhD. As the advancement of our society and the development of education, I think now college education, it becomes very basic in modern world. So for those of you who want to pursue further study, we will help you to build a solid foundation so that you can excel in future study. Our department has also negotiated terms with Columbia University so that the high achievers in our department will have a fast track admission to the master program at Columbia IEOR department. This is a very prestigious MS program, highly competitive, and I think what we have negotiated with Columbia really give some advantage to our students. I forgot to introduce myself. My name is Reijin Zhang. I'm the UG program coordinator of the department. Our department has, in recent years, we have revamped our curriculum to better educate our students in the knowledge economy. Okay, so that's a very brief introduction. If you have any questions, feel free to type in the question box, and then I'll read out your questions so that everybody will know what's being asked, and I will answer that to you guys. Okay, so let's move on. So talking about that, I would like to make some clarification of the name of our major. To be honest, this is something that I often get if at party or you go home, there's uncle ask you, hey, what do you study? If you say you study mathematics or you say you study chemical engineering, then most likely your uncle was not, okay, I know, but to be honest, as normal people, we probably don't know anything about advanced mathematics. The problem of the name of our department is that it probably hasn't yet to have a consensus meaning by the whole society. So for that, I would like to give a very brief introduction about the evolution of this area. It is called industrial engineering, most likely for the reason because the whole area originated from the Industrial Revolution. Everything's the Industrial Revolution. Let's put it that way. In 1776, the invention of steam machine and the written of the Book of Wealth of Nation, which laid the foundation for capitalism. I think that starts the whole revolution and enable us, we humans, to be able to mass produce products at large scale, to be able to transport the goods at a large scale. Because of that, there's a whole area of manufacturing, logistics, and the supply chain management. That we have been living in that world for a little bit over 200 years. But in recent, let's say, post-World War II, in recent 50, 70 years, our society has also experienced a huge change in a way that there are more service-focused industry. there has been some industry that's never appeared before. For example, finance. Finance is essentially a service industry to provide financial services, no matter commercial bank to provide financial services for normal people, and the investment bank to provide financial services for different funds, different agencies. This is essentially services. Another example of service is insurance. So for insurance, that uh, the, the way the principle it works is very simple. Is that everybody collectively contributes the so-called premium, and if one of that policyholders got involved in an accident very unfortunately, then the insurance company will help contribute financially to that guy. There's so then that what brought to the knowledge economy is that in order for the insurance to survive and to be able to sustainably provide the service, what we need is a careful calculation of the revenue and risk of insurance company. That leads to the whole kind of data and modeling. And let's give a little bit example of that. Healthcare is also another example. Um, Please don't confuse healthcare with medicine, because medicine is about medical stuff. It's about like there's a disease and how are you going to be able to cure the disease. But once we invent the protocol to cure a type of disease, for example, nowadays there are many diseases, ranges from cancer to common flu. There's a very standard protocol that doctor and nurses need to go through to treat the patient. But the question is, once we have the protocol, how are we going to be able to utilize our resources? By resources, I mean doctors, nurses, operation rooms, beds in the hospital. How are we going to be able to best utilize those resources so that, for example, the waiting time is minimized, the matching is optimized, customer experience is optimized. So that's basically the service industry. But now we enter a new era of knowledge economy. Uh, Essentially, we'll still need all these kind of services, but underneath the hood, the fundamentals are experiencing uh, a very big change. The big change is that the huge amount of data that's being enabled by the advancement of information technology. So if you remember in the old days that you're gonna use a little cassette or CD to listen to music, because we didn't have that advanced IT equipment. Nowadays, in your pocket, in your smartphone, you have thousands of songs. Similarly, 20, 30 years ago, you have use this kind of film to take a picture. So it is very rare to take a picture. I mean, through a normal person's whole life, he probably wouldn't be able to have hundreds of pictures taken. But nowadays with a smartphone, I mean, just think about the newborn baby. The parents will take tons of pictures every day. So we just have lots of information. Let's just serve as example. Nowadays, all your financial transactions being recorded, all your financial claims. I take auto insurance, for example. There are little devices can be embedded in your car and to record your driving behavior. And now we don't need to evaluate your risk simply based on your gender, based on your marital status, based on age. Like in old days, the auto insurance industry is very simple. If you are a young man, let's say unmarried, early 20s young man, you will be regarded as risky type because that's the only thing we can do. But now with advanced data, if we have all your spending behavior, for example, whether you are responsible for your credit cards, if we have the driving data, that whether you drive carefully, whether you have a lot of speeding, even that wasn't caused by a policeman, we know a lot about your personality, your reliability, and from that, we can actually more accurately evaluate your risk of getting involved in an accident. And from that, we can give you a better or more fair price of insurance. So that's just an example that why I say that in the service industry, fundamentals are experiencing a huge amount of change. Another thing is that in the past, you go to wet market, you buy pork, you buy beef, and that's it. Nothing has been recorded. Now you go to park and shop, you have your little membership card. So actually, your purchase is all being recorded. And to be honest, the shops would be able to know your preference. Do you like beef more than pork? And they also know your pattern. Like, do you do shopping once a week, or you're in a more leisure lifestyle that you probably will buy grocery a couple of times per week, and also your spending behavior. And based on that, we can actually provide you more accurate information. Some information I don't even call it advertisement, but just personalized advertisement to tell you, okay, oh, there's a discount off your favorite rib, so you probably want to check it out. So because of that, we are now entering into a new era of knowledge economy, and three things becomes very relevant and important. That's what I wrote ABC at the bottom of the slides. A means AI, B means big data, and C means cloud computing. But I should remind you that this ABC it's a huge area, interdisciplinary area. And what we're going to study in our department actually sits in the center of ABC. Let me explain why. By the way, feel free to interrupt me with any questions you may have. Okay. If I don't see anyone typing question, I'll just give you a recap of the slides. Most of what I'm talking about you will be able to find that in the YouTube link that we send it out. So you see on this slide, I draw three circles. And the center, the overlap of the three circles is essentially what I call the knowledge economy, or what I call the AI, big data, cloud computing. Okay, so first of all, you need domain knowledge. By domain knowledge, I mean the very specific knowledge of how a particular industry is working. If you work in the finance industry, you probably want to know how the stock, the option, the future, all these kind of financial instruments works. So that is the domain knowledge. Without knowing the domain knowledge, there's no way you can proceed with the analysis, proceed with designing all the strategies. Right? Similarly, for logistics, you need to know how our modern logistics is working. In ocean liner, there's a box, and how the price is set, how this space on the vessel ship is sold, and the whole supply chain network, how that forms, and what are the parties involved, and how do they do the financial transaction. All this is like domain knowledge. Okay, so but if you only have the domain knowledge, that won't take you too far. That's what basically like what's being done in the traditional education. Okay, you study logistics. Okay, that's logistics. It's basically to teach you some domain knowledge, and probably with a little bit of analysis, but most likely focus on domain knowledge. And the consequence of that old way of education is that makes the skill that you learned in college not so portable. And for example, a few years after graduation, if you want to change your career path to a different domain, that's going to be very difficult for you. Right? So that's why we have revamped our curriculum. We won't have a core, but domain knowledge is just part of the things that we cover. And we have chosen four very relevant domains, which I will tell you in detail. But the first circle that I have it here, that's the domain knowledge. A second circle is the mathematical model, or what we call analysis. Because if you only know the domain knowledge at the high level or at the sort of knowledge level, you won't be able to do a whole lot about that. It just basically know some knowledge that other people didn't know. But what we want our students to be able to do is to build a mathematical model based on the domain knowledge. Take finance, for example. If I give you limited capital, say you're managing a fund of $10 million, now the questions with all the government bonds, the stock market, the options, futures, how are we going to create a investment portfolio so that either the return is maximized or the risk is minimized. It also depends on your client's requirements. If your client is more risk averse, you probably want to minimize the risk by taking a moderate profit. But if your client has a very big risk appetite, then you probably want to have a more aggressive investment plan in a way that the profit is maximized. But of course, you expose to a larger risk. Of course, there's always a profit risk trade-off in financial investment.
Somebody asked the question.
Good. I see someone asked a question. Okay, a couple of questions. So let me interrupt my speech and just repeat the question. So the first question is, which type of modeling is most frequently used? More optimization model problems? Well, that's a very good question. Okay, so we have 4 domain knowledges. Specifically financial engineering, consulting services, logistics, and manufacturing. Okay, in all of these models, it involves making decision in an environment there's going to be some randomness. For example, if you want to decide the price of the shipping box in ocean liner, but you don't know the economic situation in next season or in 3 or 4 months, so it's basically a stochastic model. There has to be some randomness that embedded in the model. That's number 1. Second, as you point out very precisely, that in all modern business, we either want to maximize our profit or minimize our risk or maximize our revenue or minimize the delay, all these sort of things. So yes, there in all of these models, there will be a optimization involved, because ultimately in modern business, and you want to make optimal decision. But I want to add one point on your optimization. First of all, it is true, it is essentially optimization model. A second one is that the world is very complicated. For example, taking the investment, for example, there's going to be a return or profit. There's going to be risk. So there are 2 dimensions that you need to consider. And in fact, in most of our practical application, it is so-called multi-objective optimization problem. So then you have to learn some basics like efficient frontier. That means you already have the best trade-off, all these sort of things. So it goes a little bit beyond optimization. So that's basically my answer to the first question. If you want to have follow-up questions, just feel free to type in and I'll read it and I'll just repeat and answer. Okay, the next question is that, do we need to study on the School of Engineering for 1 year before we choose the major? The answer is yes. So now I think UST, not only UST, I guess most universities in Hong Kong, we have adopted this so-called school-based admission. So you will be admitted not to our department. Our department is one of the departments in engineering school. You will be admitted to the School of Engineering. And you will be required to take university core course. Calculus, algebra, physics, like there's what we call U core. And of course, in engineering school, during the first year, we're gonna have each department will have a number of introductory courses that you are free to sign up. And it's gonna be after a year of study. Actually, after half a year, a little bit more than half a year of study. you will sign up for different departments. Of course, there's internal competition, there's internal selection, but what we try to do is that we try to maximize the match. In the past, we can guarantee like most of the students will end up getting their first or second choices. Okay, so the next question is, for the financial modeling study, what is the main difference via fintech study? Okay, that's very, very good. Very good question. Well, thanks for bringing this up. To be honest, I don't see there's a clear boundary between financial engineering and fintech. What I want to say is that they belong to the same category. Let me just quickly flip my slides to this one. You see the title of this slide is financial engineering, but to be honest, I mean, you can change that to fintech. I don't see any difference here. Is no matter what you call it, right? You can call it Paul, you can call it Jack, you can call it Jim Johnson. So how we call it is one thing, but you need to pay attention to what it actually is. So this area is actually a interdisciplinary subject which applies quantitative tools and engineering methods to solve financial related problems. So this is what I call financial engineering, but also you can call it fintech. But I want to add a little bit that is fintech is together with financial engineering, they are not the words that the whole society has reached agreement on. So for example, fintech includes blockchain. Okay, so I have these slides on blockchain. A lot of people, if you ask some CS people, they will say, fintech is blockchain. Well, but I would say, yes, it includes blockchain. So this is an example of blockchain. You can check out my video for a little bit detailed explanation. But my point is that even for this blockchain, it involves a stochastic model because in blockchain, it's a decentralized open system that provides financial services, especially for recording transactions. And you see in this one that this is open network, and that there's there are honest people and there are malicious people on that. And then the system will be is built in a way that hope is robust enough to handle attack. And the study of attack is essentially a probabilistic model that you will learn in our core course of engineering probabilities that will help you to calculate the probability that, for example, blockchain system will be attacked. And this is another type of model, although optimization is not involved, but the stochastic or the random elements is involved. Okay, that's the question about clarification between the difference of financial engineering and fintech. In short, I don't see there is much difference. Both of them can be broadly defined as the interdisciplinary subject, applies quantitative methods and the engineering methodologies. And following up on the answer to this question, I think what our department is teaching is the core skill sets of modeling to handle all kinds of fintech or financial engineering applications. But of course, since one of our domain-specific areas is financial engineering, we also have several advanced courses in the related subjects. For example, we have introduction to fintech courses, which you are taking year 3. We have data-driven portfolio management courses, which will be offered during your year 4 or year 3. So that's all about what our department can provide in this interdisciplinary subject. Okay, there's additional question. Okay, so yes, so Terry is asking this course is since which year? Maybe to answer your question, I think it's best for me to jump to. Okay, so maybe my mouse is not working properly. So let me jump to the course curriculum. Okay, see, like in your year 1, you're gonna take U-Core, you're gonna take the fundamental engineering courses. That's year 1.
source that?
Oh, yeah, we just finished revamping our curriculum. I think the students get involved last year are the first batch will fully take the new curriculum. And of course, for you guys who will enter in 2024, will also benefit from the new curriculum. But yeah, so maybe I just finished on this point. Thanks for reminding me. Year 2, you're going to take our department core courses, which I will talk a little bit later. Actually, that's already in the video. So year 3 and year 4 is where you start to focus on your domain-specific courses. Like for financial engineering area, you're going to focus on risk management, quantitative methods, numeric methods, all these courses that I just mentioned. Okay. So I just got a notification says the network is not good, but okay, I think it's back to normal. All right. If you guys cannot hear my voice clearly, just shout out in the question so that we know there's a network problem and we can diagnose quickly on our computer. There's one more question. Jason is asking, any internship and exchange opportunities? Okay, good. That's so that's two questions, right? Internship and exchange. So let me first talk about the exchange. Our university has signed up the exchange agreement with lots of universities, mostly top ones in the world. So in the past, students study in our department has exchanged at those universities. I mean, there are a lot more, but I just want to list the top ones: Berkeley, Columbia, Northwestern, Georgia Tech, Toronto, Purdue. And I want to point out that our department and the IE department at Northwestern University in the United States, they call IEMS, Industrial Engineering and Management Science, but we have very similar curriculum design. So we have very good department to department relationship, and in the past, we exchange 2 students mutually. So we send 2 over there, they send 2 to us. And what I'm being very grateful to the IE department at Northwestern is that they have a specialist who help our students to settle down in Northwestern, including, select courses, or even life-wise, how we're going to be able to settle down, adapt to new environment. So I think lots of exchange opportunities in our department. That's the exchange. About internship. So first of all, we're trying really hard to talk to different companies so that our student will get some advantage when they apply internship programs. In the past, our student has got internship at very, very decent companies like Disney. I mean, these are not what we expect. These are the historical data. So we had a student did internship at Hong Kong Terminal, Hong Kong Airport, NXP. By the way, NXP is the semiconductor company who makes the chips, a lot of small chips in your iPhone, for example. We also have students interns at HSBC, JP Morgan, Goldman Sachs. So I think the investment bank also like students with the kind of skill set we're trying to teach to students. At department level, we have been working very closely with companies. For example, this year we are working with Covestro, a chemical supply chain company, on 2 final year projects. Actually, one of the team also interned at this company last year. We're working with Tongas on a FYP, and recently PNG is getting in touch with us, and we try to establish a concrete final year project and also internship plans. So I think with all this strong industry connection that we establish with these companies, I think our students do get advantage in getting interns or even later getting a job offer from them. But of course, our department's main responsibility is to teach you guys well, to make you guys great, right? But also, once you come into our department, I think you guys need to focus on improving yourself, raising yourself to a really high level. So it's combination of all the facts. So we have wonderful curriculum, we have wonderful teaching professors, and we teach. Of course, we have wonderful students, and then we teach our students to have a unique or distinguishing skill set. And the third is that we have strong connection with the industry, and it's combination of all these three factors. I think that will enable our students to have a big advantage on the job market upon the time they graduate. Okay, yeah, just feel free to type in questions. Okay, so that's internship program. Well, thanks, Jason, for asking this question. Exchange. All right. So maybe let me return to where I was. Okay. All right. So I was talking about the domain knowledge, right, as very key elements in building a model. You see this blue circle up left is called hack. What I mean is the hands-on ability of dealing with data. So we have long passed the era of using Excel. I mean, Excel is good for TA. If we teach a size of 50 students, yeah, homework 1, homework 2, midterm 1, final exam. Oh yeah, then you compile Excel spreadsheet. Yeah, that's pretty much what Excel can handle. But if you're talking about huge amount of data, for example, financial transaction data, for example, data that happens on Taobao or Amazon every day, that's way beyond what a single computer or single Excel file can handle. So you need to have a certain amount of IT skill set in order to handle data. Please do not confuse this with programming. Okay, by programming, I mean, yeah, you use the C++ program to talk about memory management, hard drive management, CPU management. This is what I call programming. Okay, but in the modern era, in the knowledge economy, the ability to deal with a huge amount of data is essential in the success of business. And this is very much different from program. But of course, you're going to use computer program to handle data, not like this graphic user interface, because graphic user interface is very, the functionality and the capability is very limited. So hacking means using some high-level programming language, for example, Python, to handle with data. So that's why I have data on the right-hand side. And also, once you build a model, right, you shouldn't say, hey, I'm an IE student, I'm not a CS student. So you just dump the model to your business partner and say, hey, you do whatever you can, right? But of course, with the model, it's still one gap from the model to a smart business decision. That is, you need to use a certain level of programming skill to compute an optimal decision. That's why I said hack. So if you look at all these fancy words, as I put in my previous slides, AI, big data, cloud computing, I think despite whatever you call them, essentially, I think we're aiming at the same thing, which is the intersection of domain knowledge, mathematical modeling, and hacking. The core, the center of this three subject is the future, is our knowledge economy. If you want to make optimal decision in business, and you need to have a skill set that span through all the three areas, and you excel in the overlap of the three areas, I think you're not too far away from success. Okay, so given that background, I'd like to introduce our.
Somebody asked the questions.
Great. And very good timing. Okay. So Terry is asking a question. A AI big data computer.
ABC.
ABC. Okay. ABC. Then what is the course difference vs computer science? Course niche but look similar indeed. I'm a parent.
Oh, she's a parent.
You grad in the 1980s. Wow. Hello. Wow. Terry, thanks for asking that. Yeah. Yeah. 1980s. Well, I think my age is assists somewhere between you and your children. I went to university in 1998, so I guess I'm maybe 15, 20 years after you, and your child is 20 years after me. So a lot of things has been changed. Things you were in college and things I was in college. So as I said, the computer science course is mostly about system management, memory allocation. If you write, for example, if you want to write a matrix manipulation program, you need to think about, do we use float or do we use double, and how big the matrix is, and depending on that, you're going to allocate a certain amount of space in the memory, and so that you then the next thing is that you instruct the CPU to do the computing and then return the results either on a screen or print that in a file. So I think that's what the traditional CS curriculum is about. It's about they learn C++ programming, they learn assembly language, which is a low-level language that directly instruct on the CPU, and they also in modern era, I mean, since the booming of internet, the network is also added to the CS curriculum. For example, the internal network, the internet, the sockets, the TCP/IP protocol, all these sort of things. So that's, in my view, that's what the CS was mostly concerned with. But also CS also concerned with, for example, the algorithm, like database. If we have a very large database, forget about the domain knowledge or the business model. It's just like there's a huge database, and we use SQL or query a particular information from database. How can we speed up the search? So that's also another area that is concerned, that CS is mostly concerned. But the difference is that we are not using a computer at this low level, because the CS people has already laid all the foundations, right? So why do we need to bother our student with the compilation of a C or C++ program? But rather, there are modern language, high-level language, for example, Python. It's in my view, in the traditional sense, it's not even a hardcore or low-level programming language, but it's a high-level language that you can interact with the powerful computer, and to instruct the powerful computer to do the computing that is very relevant to the business model. You don't need to worry about memory allocation. You don't need to worry about the CPU thread allocation or scheduling. But all you need to worry about is that how should we compute based on mode. So let me give you one example. So we did a project with the largest logistics company in China. Well, they have 3 billion of shipments every year. So 3 billion. And each shipment, each package, there are like this kind of address or this kind of container or weight. So we built a model that can help them to detect the fraud, because sometimes people will forcefully to claim that the package is damaged. So we try to identify highly risky package. So we tag that in that way. The delivery man will not just drop it in the mailbox or drop it at your doorstep, but instead will deliver it by hand and taking a picture. So in that way, we help the company to save a lot of claim due to this kind of fraud. So that's what I regard as the difference between our computing and the really like low-level computing that concerns with the system management in computer science. Another thing I want to follow up on this is that this so-called AI. But essentially, AI is developed with the advancements of hardware. To be honest, like neural network or this kind of image recognition is one example of AI. that was invented basically in the 1990s. Well, it can even date back to 1970s by some Russian mathematicians. But it wasn't developed because the limitation of hardware. But you think about the computer in the 1980s or even in the 1990s, those computer was not capable of processing images with millions of pixels, and I'm talking about thousands of pictures. But recently, right, in the past 10 years, with the advancements of GPU hardware, we're now able to do this kind of perform this kind of computing. So that's give rise to the whole AI level. I think the CS played a role of laying the foundation. So the reason that we can call Python package to operate on some image, because there are some hardcore general purpose programming that has been already implemented by CS people. As I said, the implementation of those codes has very little to do with the business model, but has a lot to do with the hardware, CPU, GPU, multi-core, parallel programming, all these sort of things. So that's the biggest difference. I hope I answered that question. If you have further one, just feel free to type in the box, and I can see that. So actually, following up on this question, let me introduce the core, the strong core of our department. There's a university core, as I said. There will be calculus class, algebra, all this very foundation class. Here, I also want to tell our young students, when you start to learn calculus, you will find this very difficult. You cannot see the application. Of course, I understand, but trust me, those foundations are very, very important. Okay. Build on that foundation, we also have our department core. Sitting in the center of the core is a sequence of courses we call probability, statistics, and predictive analytics. The predictive analytics, especially in this course, it can be named machine learning, but I just don't want to use the buzzword. Essentially, we're going to teach you some machine learning algorithm, like image recognition, like SVM, or like classification, all this sort of machine learning algorithm. We're going to teach you the first, what is the mathematical principle behind it so that it can work. And second, we're going to teach you how to use Python to call those packages to quickly process on some images. For example, you will be able to write a Python program, not so long, to read about 10,000 pictures of dog and cats, and then you will be like, if I give you a future picture, you will be able to identify whether there's a dog or cat in that. But we're not concerned with the fundamental level to how to instruct the GPU to do the computing. But so that's why I said, there's a difference. There's a different level. One is at the application level. One is at the fundamental level that directly touch on the computer hardware. Our department, we're not doing the level that touch on the computer hardware. The probability and the statistics are has been traditional taught, I think, in the 1980s or 1990s. So we had course, but we teach them in a different way, other than teach the student the theories, the basic theory of probability and statistics. We also use Python and a rich tool set that Python provides to let a student to perform Monte Carlo simulation, for example, to handle data. So this is a sequence of courses, probability, statistics, and predictive analytics. Well, we're going to teach students a couple of things: mathematical foundations, principles why this kind of algorithm works, and also hands-on ability to deal with data, to use computer to run simulation, to estimate some probabilistic quantities. So I think this kind of skill set is very portable because it can be applied in various industries. It's also very important. As I said, nowadays we're not going to simply use Excel, but if you can use Python to instruct a computer to perform tasks at a large scale, then you can often help your business make better decisions. We also have the database courses. This database courses is basically relational database, how do we query, all these sort of things. We also have system simulation. This is a more advanced simulation. For example, we can simulate a whole manufacturing line in order to come up with the best scheduling policy of your limited resources. You can perform simulation of an emergency room to see how do you handle patients with different severity with your resources is the most efficient. We also have stochastic models, which will teach you how to embed different kind of stochastic elements into business model. For example, there's a very classic model called news vendor. Basically, you need to, for example, you need to buy newspaper from the publisher in the morning, right? And then you can sell the newspaper throughout the whole day. But the challenge for you is that you have to decide the number of newspaper you buy at the beginning of selling horizon. News vendor is just a name. It can be applied in, for example, fashion industry. For example, Zara has to decide how many, like a particular lady's skirt, how many to produce before the selling season, right? But you don't know. I mean, there are all kinds of randomness, the economy, how customers take on this, whether your competitor come up with more favorable kind of design. You don't know. So, but you have historical data. So how are you going to be able to use historical data to estimate the randomness and to incorporate that randomness into the business model so you can produce the optimal number of dress so that your risk is minimized. So thanks, Terry. You asked another question. What is the high and low DSE result for student intake 2 months ago?
To engineering school and
yeah.
Yeah.
Okay, well, thanks for bringing this up. So Maggie is open up the slides.
It's median, it's lower quartile, and it's the subjects. But we don't have the highest and lowest, we have the lower quartile and the median.
Yeah, but let me try to figure out this question. So what is the high and the low result for? So Terry is asking about the statistics.
Yeah, the best and the worst students who enter output.
Okay.
But then we are the school-based.
Yeah. So okay, so first of all, we are school-based admission. They enter into engineering school, not our department. It's after 1 year they're gonna select. After half year they're gonna select a major, and after 1 year all the selection will be done. So what I can
share the link to that.
Oh yeah. So what Maggie is gonna do is Maggie is gonna type the link of a very brief summary of the score. It indicates the not high and low, right? It indicates
the median and lower quartile.
Yeah, the median and lower quartile. So anyway, Peggy will type that in so that you can read the data, the scores. So in general, I mean, I think UST, of course, if you talk about the best students or the highest score that we admit, I think that will be very close, or that's the full mark. But also, if you talk about school based admission, I think, yeah, I see some point 3 and 4.
Maybe there's a score calculator.
Is there slides? Yeah, you can send this page. Okay, so Maggie will send the URL, the link about the calculator, so you can even play with that a little bit. Yeah, JUPAS score. Okay, good. Calculator. Okay, so it's the space. No, space. Okay. Yeah. Okay. Cool. Yeah. Okay. So I hope you can play with that. Okay. All right. So Okay, so for the core, maybe let me just continue with these slides for the strong core. I think for computer programming, I mean, if you look at this course, the lower left one, computer programming, what I mean is Python, Python programming. It's a high-level programming language. I think it's very easy to use. I think it's closer to Excel, in my view, than to C++. But of course, Python is a full-fledged computer language. It's very powerful. I think with a skill in this language, I think it will certainly give you a lot of advantage on the job market. Of course, we're going to teach our students microeconomics, engineering economy, and accounting. Those are like basic courses that will give our students some sense of business, which is, I think, also very important. Build on this core, we have 4 domain-specific areas. We divide our programming into 2. So we have Bachelor of Engineering in DA, Decision Analytics. We also have Bachelor of Engineering in the IEM, Industrial Engineering and Engineering Management. So for DA, there are 2 areas. One is financial engineering, the other is consulting services. I know this word is, you're not that familiar with this word. I'll explain each of these 4 areas later, okay? IEM includes engineering management and logistic management. Okay, so financial engineering, as I said, this is an interdisciplinary subject that applies quantitative tools and engineering methodology to solve financial related problems. For example, the design and pricing of financial options is also, I mean, this is very typical application, just try to give you some idea. If you look at this table is from Wikipedia. I think Hong Kong is the number 3, the most important financial center in the world. Of course, we are facing very severe competition from Singapore, but I'm very positive on the future of Hong Kong. So this area is very relevant, both locally and globally. Just want to.
Have 3 minutes left.
Oh, okay, yeah, but okay. So I already said maybe just finish up. A typical example is like how could Cathay Pacific or McDonald's offer a stable price, but for them they are facing a huge volatility in terms of crude oil price, in terms of for McDonald's. If you think about chicken nugget, right? You go to McDonald's today and tomorrow, you buy chicken nugget at the same price. But McDonald's is facing a huge volatility because they buy the material from market, or the chicken meat price fluctuates quite a lot. So then we're gonna use some design of financial instruments to hedge against the risk. So that's basically financial engineering. So time is up. Well, I want to thank everybody for attending this session. Again, we posted the video of the YouTube talk. You're welcome to watch the video. I think most of the presentation about slides I talk is in the video. Oh, last question, Terry. Okay, so Terry's asking, what is the career title that you will think of for fresh graduate students of this course? Programmer, system analyst, business analyst. Wow, thank you. This is a very good question. Okay, I think this is a very good question to wrap up my session today. So let me just go to this page, career opportunities. I think because our area is an interdisciplinary area, and our students, according to historical data, our students went to a variety of industries. So these are data, okay? These are not speculation. So our student will get the consultancy job at, for example, Hong Kong Product Council, Accenture. Accenture is a consulting company. They will go to finance industry, service industry, engineering management industry, logistics industry, and so on and so forth. You can check out this in my YouTube talk. As to the title, I think if you go to investment bank, for example, Goldman Sachs, you will start off as analyst, And after a few years, normally 3-4 years, but of course depending on performance, will be performed to associate, and later on they call it VP. Some investment call it the ED, executive director, and later on managing director. This is a very challenging path, to be honest. But if you like the challenge and you like the kind of vivid environment in finance industry, you can choose that. For logistics, normally you're gonna be a management trainee, assistant officer, and like there's a research track. If your children are interested in pursuing, for example, PhD study, and then like me, well, you get a PhD and then assistant professor, associate professor, you can end up a career path in universities. You can also go to industrial engineering, like Disneyland. Disneyland actually need a lot of analysts or IE students like our students. You're going to be industrial engineer, senior industrial engineering, project engineering, operations manager, and so on and so forth. So for, I mean, different company, they for the entry level, they make quite a different thing. Some call it associate, some call it analyst, some call it trainee or industrial engineer, or in recent years they have data analyst or data scientist. They have data scientist 1, data scientist 2, or they have junior data scientist or senior scientist. But I think what's behind this title is the reflection of the nature of their job, which is to which is, as I said, sits in overlap of the 3 majors: domain area, modeling, and computing. I think that's what essentially your children will be able to do after going through our program. Okay, well, thank you, Terry. I think you asked a lot of very good questions and shaped my presentation today. So I think this is very relevant. I really appreciate everybody who attends this session and ask questions. We also left our contacts on our website. We also have our Instagram, which you can find on our website, Instagram, email, phone call. So feel free to contact us, and I am looking forward to seeing you guys or your children in the coming year. Thank you very much. And with that, I'd like to conclude my session. Okay, bye-bye.
And